Hello students, I am Lekhadeep Oza, your physics teacher, and today our topic of discussion is laws of motion. Laws of motion. Chapter 5, class 11, right? Class 11. So you have already studied in class 9 the three laws of motion. Newton's first law, Newton's second law, right? Newton's first law of motion. First law of motion. Newton's second law of motion. And Newton's third law of motion. Newton's third law of motion. Right. So Newton's first law of motion is also called law of inertia. Okay. So what is inertia? Why it is called law of inertia? I will explain. It's and everything. Okay. And the Newton's second law is called the real law of motion. Real law of motion. Why is it called real law of motion? I will explain that thing also. So I will explain all the things one by one. So first, let me explain about the Newton's first law of motion. Okay. So what does it state? Let me write the statement of Newton's first law and why it is called law of inertia and what do you mean by inertia. So let us discuss all those things first. So now you see Newton's first law of motion. It states that every object continues to be in its state of rest or uniform motion in a straight line unless and until an external force acts on it, right? So it states that every object continues to be in its state of rest. That means now you see this is an object at rest or uniform motion. Let me consider another object which is in uniform motion. Let me take the case of a ball which is rolling over a surface, right, in this direction, suppose with velocity v. Let me suppose that. So now this object is at rest, right, and it is moving with velocity v in this direction. Now until and unless if you apply a force here, it will not move, right? Will it move? Definitely not. Until and unless if you apply a force, it will not move. When you will apply a force in this direction, it will move in this direction. If you apply a force on this object in this direction, then it will move in this direction, right? Now you see, this is the ball. If you roll it over a surface, it will cover a certain distance, then though you don't touch physically, it will stop. But according to the law, it should be moving with uniform velocity, right? With the same velocity in a straight line, it should be moving, right? But why does it stop? What do you think? What should be the cause behind it? Unless this is the ball, you have thrown it and it is rolling over a surface, and you haven't touched yet physically after it is thrown, right? But why will it stop? Because you see, when it is rolling over the surface, there must be a frictional force, right? There will be air drag as well, and also gravitational force, right? These are the external forces that those will stop this ball, right? Hope it is clear. If there is no gravitational force, no air drag, no friction, there is no any force which resists the motion, then it will always be always moving in the same direction with the same velocity. Is that clear? That is what explained by the Newton's first law of motion, and this law is also known as law of inertia of motion. Why? So what do you mean by inertia? Inertia means, now you see, when you force an object to change its state of motion or state of rest. Suppose this is at rest, when you apply force to make it moving, right, to set it in motion, or when you apply a force against the motion of an object to stop it. So those objects, they have a natural tendency to resist the change in their states of rest or motion. The tendency is nothing but inertia, right? That property is called inertia, and this law says that every object continues to be in its state of rest or uniform motion. If every object continues to be in its state of rest or uniform motion, that means unless and until an external force acts on it, every object has the tendency to continue their state of rest or uniform motion. That is nothing but the property of that is the property of the object, which is called inertia, right? That is explained in Newton's first law. That is why this Newton's first law of inertia, Newton's first law of motion is also known as law of inertia. Hope you have understood this. Because you see, let me explain it again. Okay, let me explain it again. So here you see every object. So let me write the definition of inertia, right? The property by which an object always tends to be in its state of rest or uniform motion is called inertia. is called inertia, right? This property is called inertia, right? That is why this Newton's first law of motion, which explains that every object continues to be in its state of rest or uniform motion in a straight line. In a straight line, I missed the word line here, unless and until an external force acts on it, right? So that is why Newton's first law of motion is known as law of inertia. Okay, so hope this thing is clear to you. Now let us discuss the second law of motion. So what is the second law of motion? Let me clean the board first. Okay, so Newton's second law of motion. Newton's second law of motion, right? And it is the real law of motion. I will explain why it is the real law of motion after after explaining the third law. Okay, so here you see. So what is the Newton's second law of motion? What does it state? So it states that the rate of change of momentum of an object is directly proportional to the force applied on it in the direction of its motion. Now you see, before I explain this law, let me ask you, what do you mean by momentum? So you have already you have got this term also in class 9, momentum is equal to mass into velocity, right? Mass into velocity. Suppose this is an object of mass moving with velocity v, then its momentum p is equal to m into v, right? We denote momentum with the help of this letter p, right? So hope you have understood this. So this is momentum. The rate of change of momentum of an object, it depends on the force, right? It directly proportional to the force applied on it in the direction of its motion. So now you see, let me give you an example. Suppose this is an object, it is moving, its mass is suppose 5 kg. It is moving with velocity suppose 3 meter per second. It is moving with 3 meter per second. This is its initial velocity u, right? It is moving with uniform velocity u, and a force is applied on it. Suppose it is F1, right? And due to the application of this force after time t, so this force suppose acts on it for time interval t, its velocity becomes, final velocity v becomes suppose 7 meter per second, right? 7 meter per second, right? So what will be its change in momentum? Now you see here, in this case mass of the object m is 5 kg, right? I have taken 5 kg. So what will be the initial momentum? Pi, let me write Pi means initial momentum. So m into u, that's gonna be equal to 5 into 3, that's gonna be 15 kg meter per second. And what will be the final momentum? Pf, that's gonna be mv. So mass is 5 kg, v we have got 7, right? 35 kg meter per second, right? So what will be the change in momentum? That is given by Pf minus Pi. Let me represent it by del P. That will be 35 minus Pf is 35 and Pi is 15, right? That's gonna be equal to 20, right? 20 kg meter per second. That is the SI unit of momentum, right? So that will be the change in momentum. And what will be the rate of change of momentum? Del P by del T. That will be Pf minus Pi divided by T, right? So if suppose it takes 10 seconds, to reach this velocity, then here we're gonna write T. T instead of T we're gonna write, so time taken is 10 seconds suppose to reach the velocity 7 meter per second. Then the rate of change of momentum will be 20 by 10, right? That is 2, right? 2 kg meter per second square, right? Now you see, let us take another situation. This is an object of same mass, equal mass, 5 kg. It is moving with same initial velocity, 3 meter per second, and we have applied a force along its direction of motion, F2, suppose, F2, right? F2, and it's after same time 10 seconds, its velocity becomes v is equal to 9 meter per second. So what will be the rate of change of momentum in this case? In this case, rate of change of momentum del P by del T, right? Del P by del T in this case will be, the final momentum will be mass into velocity, 5 9 is 45, minus initial momentum, mass into initial velocity, 5 3 is 15, and time taken 10 seconds, kg meter per second square. So 45 minus 15, that's 30 by 10, that's 3 kg meter per second square, right? So here you see, here the rate of change of momentum is more than the rate of change of in this case, right? So that's why here you see, according to this Newton's second law, this F2 must be greater than F1, right? Because you see here the rate of change of momentum is more than rate of change of momentum in this case when you have applied force F1, right? If you apply greater force, there will be greater rate of change of momentum, right? So this is what it is explained in this Newton's second law. That means the rate of change of momentum is directly proportional to the force applied on it. So now you see, the force applied on an object is directly proportional to the rate of change of momentum. Del P means change in momentum within time interval del T, right? So now let me explain the mathematical formulation of Newton's second law of motion, right? That means when we say Newton's second law, this formula F is equal to ma comes to our mind, right? So how do we get that? Let me explain. Now you see, This is an object of mass m moving with velocity, initial velocity u. So velocity is a vector quantity. Let me write here arrow symbol. So in your book, if you get bold letter, then that means that is vector quantity, right? Instead of writing arrow in your NCERT book, they are using bold letter to represent vector. Okay, so hope you know these things. So now you see it is moving with initial velocity u, right? Due to an application of force F, its velocity after time del t, its velocity becomes v, right? So what will be its initial momentum? Initial momentum pi, let me write pi, means initial momentum. Initial momentum pi, that's going to be m into u, right? And final momentum pf, that's going to be m into final velocity v. Initial momentum, mass into initial velocity, final momentum, mass into final velocity, right? Hope this thing is clear. So change in momentum, that is given, that is written as del p, which is equal to pf final momentum minus initial momentum pi. So that's going to be equal to m capital V minus m into v minus m into u. Final velocity, initial velocity, final momentum, initial momentum, mass into final velocity gives final momentum, mass into initial velocity gives initial momentum, right? So what will be the rate of change of momentum? Rate of change of momentum. That will be del p by del t, right? Del p by del t, that's going to be mv minus mu divided by del t. So m is taken common, v minus u by del t. So v minus u gives you change in velocity. Let me represent v minus u by del v. Let me represent it by del v, right? So we can write m del v. Del v represents change in velocity, right? Del v. This is what? Rate of change of momentum, right? According to the second law of motion, according to the second law of motion, the force applied on the object in the direction of motion, that should be directly proportional to, that is directly proportional to rate of change of momentum, that is del p by del t, right? Del p by del t, right? Now you see, so this is proportional. That's why in order to equalize, we need a constant. Let it be suppose k, del p by del t, right? Now you see, here, if you take limits, taking limits, del t tends to 0, del t tends to 0 means very small time interval. That means suppose the velocity that you have calculated at this moment, the time is suppose 5 seconds. 5 seconds after it starts to move. and this time is suppose very small. Here this is t1, this is t2. After a very small interval of time, suppose this is suppose 5.000000 1 0 0 1. So here you see between these two the time interval is very small. This is 5 seconds, this is 5.00001, right? So that means del t tends to 0, means it is not exactly 0, it is very small, right? It's tending towards 0, right? Okay, so now you see, suppose you have time interval del t is equal to suppose 5 seconds, 0.5 second. If you make it if you take a smaller time interval than this del t, suppose now you have taken a smaller time interval, let me take 0.05. okay, and if you reduce it more than 0.005, then again 0.00005, and so on, then we say del t tends towards 0, right? So hope you have understood this concept. So then what you can write? You can write this this del p by del t. If you take limit del t tends to 0, del p by del t, del p by del t is equal to limit. So m is mass is constant, so let me write here, then let me write limit del t tends to 0, del b by del t, right? So we are taking limits del t tends to 0, that means we are taking the rate of change of these quantities, here momentum, here velocity, within very small interval of time, right? So then this can be written as dp by dt, right? This is called differential coefficient of p, and m, this can be written as dv by dt, right? And dv by dt is nothing but acceleration. Acceleration is rate of change of velocity. Hope you have already got earlier, right? In chapter 2, 3, right? When you have studied motion in a straight line, when you have studied motion in a plane, right? You have already got these things, right? So now you see, so that's why when you take limit, you can write f is equal to k into dp by dt, right? dp by dt, which is equal to m dv by dt, right? So if you replace it by m dv by dt, you get k into m dv by dt. So what is k here? K is the constant of proportionality. K is the constant of proportionality, right? Then we will get this relation here. What we have got, is equal to k m dv by dt can be replaced by acceleration a. Let me write here a. So we have got this relation. Okay. So hope you have written those things. So let me clean this board. Let me go to the next step. Now you see, by the definition of 1 Newton force, by definition, 1 Newton force is equal to 1 kg into 1 meter per second square. So what does it mean? Suppose you have a 1 kilogram or 1 kg object, 1 kg mass. If you have applied a force F on it, because of which it accelerates through an acceleration of 1 meter per second square, then this force will be 1 Newton, right? So you have already got this definition of 1 Newton force in class 9, if you remember, right? So this is the force, this is mass, this is acceleration, right? So if you put those values, if you put the magnitude of these quantities here, then you should get, this is suppose equation number 1, then from 1 you should get 1 is equal to k into 1 into 1. So k will be equal to 1. If k is equal to 1, if you put the value of k here, then you should get F is equal to ma. This is the mathematical formulation of Newton's second law. So this is the mathematical formulation of Newton's second law of motion, right? Hope these things are clear to you. So now let us discuss Newton's third law of motion. Then I will explain why the second law of motion is called real law of motion, right? So let me go to the third law. So Newton's third law of motion. Suppose this is a wall and you push the wall with a force F, then according to the Newton's third law, this wall also push you back with the same amount of force but in opposite direction, minus F. This minus represents opposite direction, right? So that means we can say that Newton's third law states that to every action there is an equal and opposite reaction. Equal and opposite reaction. Right? This is the Newton's third law. So you can take the example of firing a bullet, right? When you fire a bullet from a gun, then as soon as the bullet moves out from the gun, you will experience a force in opposite direction, right, towards you. That means the gun will exert force towards you. It will try to move towards you, right? So similarly, when we walk on a surface, this is the floor, and when we walk, our legs exerts force in this direction, then we used to move forward, right? When our legs push the ground behind us in backward direction, ground push us to forward direction. That's how we used to work, right? So this is explained by Newton's third law of motion, right? So now you see, I have already told you that Newton's second law of motion is called the real law of motion. Newton's second law of motion is called real law of motion. Right. But why? Now you see, from the Newton's second law of motion, you can explain the first law, and you can also explain the third law. That means first and third both are contained in second law. That is why Newton's second law of motion is called the real law of motion. So now let me show you. Now, according to Newton's second law, from Newton's second law, we have got that F is equal to ma, right? F is equal to ma, right? So F is equal to ma, dv by dt. Acceleration is nothing but dv by dt, right? Rate of change of velocity, right? So if you get the vector here, then you should write dv by dt. Okay. So when there is no force acting on an object, this is an object of mass m. Okay. It may be at rest or in uniform motion. Uniform motion. That means there is no external force. No external force. Then this force is equal to 0. So dv by dt is equal to 0. So if you divide both sides by m, then you will get dv by dt is equal to 0. So in mathematics you must have got that derivative of constant is 0, right? Derivative of constant is 0. So that's why, as we have got derivative of v is 0, so v is constant here. That velocity is constant. That means it is not changing. When it is not changing, why it is not changing? Because here we have taken force is equal to 0. The external force is 0. That means we are not applying any force. So what was the first law? First law says that an object continues to be in the rest, in its state of rest or uniform motion, unless and until an external force acts on it. Okay. So when until and unless if you don't apply any external force, that means F is equal to 0, then this V is constant. V is constant means velocity is constant means if it is moving with a fixed velocity, a uniform velocity, suppose 5 meter per second, it will continue moving with 5 meter per second. If it is at rest, that means V is 0 unless and until you apply an external force, it will be at rest, its velocity will be 0, right? That is what we have obtained, that V is constant when F is equal to 0 from this second law, right? Hope you have understood this. Now from this second law, let us obtain the third law. So now, before I explain how to get the third law of motion, third law from the second law, let me explain the law of conservation of momentum. Law of conservation of momentum. So I will prove this law also. I will show you how to prove this law. So just for the time being, let me explain only. Let me explain the statement of this law, because we must know this law in order to understand how to obtain the third law from the second law of motion, right? So after explanation of this topic, I'm going to explain and I'm going to show how to prove this law of conservation of momentum. Okay, so this law of conservation of momentum states that in an isolated system, that means isolated system means there is no external force, external force is 0. Suppose there are two objects. This is ball A. Suppose this ball B, suppose B, and its momentum is PA, and its momentum is suppose PB, and the second one is moving faster than B. A is moving faster than B, and they are moving in the same direction along the same straight line. So then what will happen? They will collide, definitely. They will collide, right? A, B. And when they collide, the force exerted by this ball A on B, suppose F A, and the force exerted by B on A is suppose F B, right? And after collision, there will be change in momentum. So momentum of A after collision, suppose P dash A, and that of B, that of ball B is suppose P dash B after collision. So here you see now look at this. If you apply the second law of motion, how to calculate force A by the second law of motion, that will be equal to m into d PA, that means rate of change of momentum of A. So here d P, that's gonna be equal to PA dash minus PA. Final momentum is P dash A and initial is PA, right? So you have understood this. So now you see by dt, and similarly FB will be obtained by MD PB by dt, right? Now you see, if you add these two, FA plus FB, then you should get M dPA by dt plus M dPB by dt. So dPB, so this is dPA and this is dPB, that is nothing but PB minus P dash P minus PB, right? Now you see, if you take the M common, then you can write dt is equal to PA plus PP, right? PA plus PB. Okay. Now look at this. According to this law of conservation of momentum, total momentum before collision, PA plus PB, is equal to total momentum after collision, that is P dash A plus P dash B. So that means you can say PA plus PB is equal to constant, is equal to constant, is equal to constant, right? So if this is constant, that means total momentum is always conserved according to the law of conservation of momentum. So that's why it's going to be equal to 0. If FA plus FB is equal to 0, then we must get FA is equal to minus FB. That means these two forces are equal but opposite in direction, right? That is the third law of motion, right? And here we have used second law, right? Second law of motion. That's how we get from the second law, that's how we get third law. So hope you have understood this. So that means the force exerted by this ball A on B, if it is FA, then same amount of force will be applied by the ball B on A, but in opposite direction, right? So that is what explained by third law of motion. So hope you have understood. Explain the law of conservation of momentum. So let me show you how to prove the law of conservation of momentum. Law of conservation of momentum. It states that in an isolated system, of interacting particles, the total momentum is always conserved. Total momentum is always conserved, right? So that means, here you see, suppose we have two objects. This is moving with momentum PA, suppose this is object A. Another object B, suppose it is moving with momentum PB, right? PB, and ball or object A is moving faster than B. Then what will happen? In the same along the same direction, along the same straight line, then they will collide, right? this is A, this is B, and force exerted by A on B is suppose Fa, and the force exerted by B on A is suppose Fb. Let me write here Fb, right? Okay. So here collision, and this collision, suppose it lasts for time del t, right? And after collision they moved. Now you see the momentum of the object A, Pa, changes to P dash Pa dash. This is the object A, and the momentum of B, Pb, changes to Pb dash, Pb dash, right? This is the ball B. This is before collision, and this is after collision, right? After collision. So here we have considered that suppose two objects A and B be moving in the same direction. Let me do this. This is the proof of this conservation law. In the same direction, along the same path, along the same straight line. Okay. So according to this law of conservation of momentum, so total momentum before collision Pa plus Pb, and total momentum after collision, that is Pa dash plus Pb dash, these two should be equal, right? According to the law of conservation of momentum. Isolated system means no external force. These two forces are, you see, this existence of these two forces because of their interaction between the particles. Okay, we are not applying any external forces from outside. Is that clear? So now you see here Pa is the initial momentum of A, and Pb is the initial momentum of B, and Ps is the final momentum of A, and Pb is the final momentum of object B, right? And Fa is the force. So let me use the vector symbol here. Momentum is also vector quantity. So Fa is the force exerted by the object A on B, and Fb is the force exerted by B on A, and also mention A is faster than B. That's why they are colliding each other, right? Now you see, okay, and dt be the duration of collision. Right? Now, according to the second law of motion, right, the force exerted by A on B, that is Fa, that must be equal to rate of change of momentum of the object A. So here initial momentum is Pa and in final momentum is P dash A, right? This is the initial momentum and this is the final momentum of A, right? So what will be the rate of change of momentum? Final momentum P dash A minus Pa, initial momentum Pa, divided by duration of collision T, right? Similarly, you will find the force exerted by B on A, that will be the rate of change of momentum of B, right? That is the final momentum of B minus final momentum of initial momentum of B. Final minus initial. Final momentum is PV dash and initial momentum is PB, right? So PB dash minus PP divided by duration of collision, right? Now you see, according to the third law of motion, every action has equal and opposite reaction. That means if the ball A or object A exerts force Fa on B, then the force exerted by B on A, according to the Newton's third law, will be equal but opposite in direction, right? So these two forces must be equal and opposite in direction according to the third law of motion. Now let us use these two here, right? Then what you will get? So put these two here, then what you will get? Pa dash minus Pa by dt is equal to Pb dash minus Pb by dt, and here we have minus sign, so let us put here minus. So dt gone, so we will get, so here you see, if you multiply this minus with the term inside the brackets, then what you will get? Pa dash minus Pa is equal to P minus Pb dash minus plus Pb, right? This minus is multiplied here and here also, right? So now you see, let us bring this to this side and transfer this to that side. Then on the right hand side you will get, so let me shift this one to that side. Then what you will get? Pa plus Pb, and let us bring this one to this side. Then you will get P dash minus that's going to be plus here, Pb dash, right? So hope you have understood from this step. It is very simple simplification, right? So this is what total momentum before collision, and this is total momentum after collision. So hope this thing is clear to you. We have already discussed about the three laws of motions, and also we have discussed about the law of conservation of momentum, right? So hope you have understood this. So thank you for watching. See you in the next class.